just one example, one page example. I think yes, one page example. Okay, associated with this method. As example is show that integral minus infinity to infinity cosine 3x over x square plus 1 whole square dx is equal to 2 pi over e cube. Consider, I'm not following step by step. Now you can, for your own calculation, you can follow those, but for the sake of convenience, I am just avoiding those steps and writing some direct results over here. So we consider this f of z to be 1 over z square plus 1 square. So what is z? This is f of x basically. This is f of x, 1 over x square plus 1 whole square. So for f of z, we just replace x with z. So f of z is 1 over z square plus 1. Okay. Thus, or then we observe that f of z e power iota 3 iota z, because we are dealing with cosine 3, so we will go for this exponential 3 iota z. Okay, 3 iota z is analytic everywhere except at z is equal to plus minus iota. Singular points for this. Okay, and this has, for the given contour will be the same, because we are dealing with minus infinity to infinity. So for the contour, there is only one singularity inside the contour, that is plus iota. Minus iota is outside the contour. So we will consider only one contour, and this contour has multiplicity 2. So we will find, or we will try to find the singular residues for that as well. If the contour is this one, then only one singular points, only z is equal to iota will lie inside the contour, so that this integral minus r to r e power 3 iota x over x square plus 1 whole square dx is 2 pi I b1 means residue minus integral over cr f of z e power 3 iota z dz.
So cos 3x is not equal to e to raised power 3 iota x. You must write cos 3x as e power
Yes.
iota x plus e power minus
Yes, obviously, but here I'm, as I said earlier, I am omitting some details. So what we do, we convert this, we can write, no problem, okay. If we are going to write this, okay, you are right, minus infinity to infinity, this is real of, you can write this one exponential 3 iota x over x square plus 1 square dx. So I am considering only this function, and after that evaluating the this integral, I will take only real part. As I said earlier, in case of cosine, we evaluate that integral with exponential, and then after that we will take the real part. In case of sine, we will take the imaginary part. So I said earlier, I have omitted certain steps. I think you should follow that. So instead of this, I am considering this one. I will try to evaluate this integral, and then get the answer for this integral, and then get the real part of that to be the answer to this question. Okay?
After B1.
B1, but B1 is the residue, where B1 is the residue at f of z at z is equal to iota. Okay? Rather than not only this, along with exponential 3 iota z, whole function. Thus B1 is equal to residue z is equal to iota f of z e power 3 iota z. Now since f of z e power 3 iota z can also be written as phi z over z minus iota square, where phi z is exponential 3 iota z over z plus iota square. We are using the theorem discussed in the previous chapter, that whenever we have a function with zero with the poles, we can write here in that case. Okay, so here m is equal to 2. M is equal to 2. So what we do? We will differentiate this one time and then put z is equal to iota over there. So thus B1 is phi dash iota, and this phi dash iota is this one. You can check it. First differentiate this using u upon v formula, and then put z is equal to iota over there. You will find that phi dash iota is equal to 1 over 3 iota EQ. Also, what we have to prove here, that this integral over CR, this integral must have the value 0 when r tends to infinity. We can see here f of z, structure of f of z is given to be 1 over z square plus 1. So the mod value of this means this is less than or equal to 1 over r square minus 1. And when it is multiplied with the length of the contour, which is pi r, so this is pi r or r square minus 1. So this will give you, when r tends to infinity, this will give you 0. Okay, so the final result is that this is multiplied by, I am quickly following these steps. However, if you feel any difficulty, you can discuss in the next lecture. Okay, so this is 3 iota z dx is equal to 2 pi iota into 1 over iota e cube. So it is 2 pi over e cube, because this becomes 0 when r tends to infinity. When r tends to infinity, this will give you this result. And what is the real part? Real part is itself. So that means,
Input integration you will take x and also z.
oh, sorry, now it is x. This is x. Okay, so the real of this is again cosine 3x dx is again 2 pi over e. If you have, for example, sine over there, then its answer is 0 because there is no imaginary part. So answer to this is 0. That's all.